So let's look at this example here. This example is in your PowerPoints. Par Inc. is a manufacturer of golf equipment and has developed a new golf ball that has been designed to provide extra distance. In a test of driving distance using a mechanical driving device, a sample of Par golf balls was compared with a sample of golf balls made by RAP Limited, a competitor. The sample results appear below. Okay, and what do they want us to do? Let's see. There's a bunch of results there, and they say, okay, can we conclude at the 1% level of significance that the mean driving distance of Par Inc. golf balls is greater than the mean driving distance of RAP Limited golf balls? Okay, so basically what they want us to do here is they want us to figure out if the average distance, should I do it here? The average distance of the Par golf balls, I'm going to call that mu1 since it's the first sample. If the average distance that they go is going to be greater than the average distance that the RAP golf balls go. So that's what they want us to figure out. Now, this is a correct statement. That's what they want us to figure out. This particular statement is, well, it can be rewritten for starters. We can rewrite it like this: mu1 minus mu2. It's exactly the same statement, is greater than 0. Okay, so you could think of it, we either subtracted mu2 from both sides or we just took this over, however you know how to do it. Now, this is an alternative hypothesis. If we go back to what we did in the last lecture, we could see that mu1 minus mu2 is greater than 0 is an alternative hypothesis. So basically, we can pick up this entire scenario from here. So if you've got a cheat sheet and this is all written out, you can pick up this entire scenario and copy it over. So let's go back to the actual example. There you go. So this will be an alternative hypothesis, and the null hypothesis that's going to go with that is going to be, let's do that one there, mu1, oops, sorry, this is h0, and this is an a, this is actually an a. Get this nice and clear, or as clear as we can make it. And so we've got h0 is the null hypothesis, and that's going to just be mu1 minus mu2. Remember, the null and alternative are opposites of each other, so it's either greater than 0 or it's less than or equal to 0. So we know from our template above that this is going to lead to a one-tailed test with rejection to the right-hand side. We already know, because we know the population standard deviations, we know this is going to be a z distribution, and we know that this critical value is going to be plus z of alpha, and we already know that alpha is 1%, and so this put on the reject zone is going to be to the right hand side. So this is reject h0 over here, and do not reject h0 is going to appear over here. There you go, do not reject h0. And so all we need to do now is two things, which is one is to find the critical value, and the other thing is to find the test statistic. So critical value is, for this one, is going to just be z of alpha, as we said, and the test statistic is going to be this formula in here, which we're going to have to calculate. We can do that on Excel. So should we do z of alpha over 2 first? So z of alpha, not z of alpha over 2. So z of alpha, one tail z of alpha, is going to be z. Well, we've said alpha is 1%, so it's z of 1%. And so basically, to make this a bit clearer, what I can do a normal distribution on that. And basically, the rejection area, alpha is 1%. So this red area in here is 1%. All that area in there is 1%. So the area to the left is 99%. So this is going to be, we're going to use our norm.s.inverse, norm.s.inverse of 0. Area to the left is 99%, 0.99. Let's go over to Excel and do that. So let's just do it here. Equals norm dot s dot inverse, and it's going to be 0.99, and that comes to 2.33, about 2.33. Let's go back over here, and this is going to be 2.33, so that equals 2.33, 2.33. This is 2.33, and just need the test statistic now. The test statistic is going to be x1 bar minus x2 bar, x1, there's supposed to be a 1 in there, x1 bar minus x2 bar minus the difference that comes from h0, and that's going to be divided by the square root of sigma 1 squared over n1 plus sigma 2 squared over n2. So in the previous example that we did, I showed you how to do this in Excel. So I'm not going to do this in Excel this time. However, I'll show you what numbers you need to put into Excel. So the first thing is x1 bar. So it was the mean of the first sample. So the mean of the first sample we could see here is going to be 275, and we're going to subtract the mean of the second sample, which is 258. So that first part is going to be 275 minus 258. Okay, then we have to subtract from that d0. Now d0 is the difference. Since this is the difference, and the difference from h0, and we just take whatever number's in here, and that number is 0. It doesn't matter if it's equal to, greater than or equal to, less than or equal to, whatever that number we see in there is what we take, and in this case it's 0. And again, students say, does it have to be 0? No, it doesn't have to be 0. It can be 0, it can be any number. A lot of the time it is 0, but it doesn't have to be 0. And then we're going to divide out by the square root of sigma 1 squared, and if you look above, you'll see that sigma was 15, sigma 1 was 15, oops, sigma 1 squared divided by 120 plus sigma 2 squared, which sigma 2 was 20, so it's going to be that squared, and that's going to be divided by 80, which is the sample size of the second sample, and that's going to come to 17, approximately, so that's going to be exactly 17 over approximately 2.62, giving us a test statistic of 6.49, very large value. So let's see where that 6.49 falls. So 6.49, our test statistic, where does it fall? Well, if this is 2.33, 6.49 is going to be on the sort of way out here. It's going to be way into the reject region. So our conclusion will be to reject H0. So reject H0 means we're going to reject H0. So if you remember for this question, they actually gave us the null hypothesis to start off with, but we still run the test on H0. And now that I know I'm going to reject H0, it means that the actual assertion that they made seems good. It does seem that the par golf balls, based on this sample and all the constraints that we've got, it does appear that the par golf balls do in fact go further than the wrap golf balls. And so if you remember again back to what we did previously, this is called the critical value approach because we calculate the critical value and continue from there. And there's a second approach we could have used to solve this, which is going to be the p-value approach. So for the p-value approach, what do we need? We need the test statistic, which was 6.49, it's up here. So 6.49, and we need to find the area in that tail, the area in here. And we know it's a normal distribution, and so we're just going to be using 1 minus norm.dist norms.dist of 6.49 and true or 1. Okay, so that's going to give you a value that's going to be approximately equal to 0. And what do we know? In this particular case, we know that the p-value is 0, and we've got some results from before. Do you remember if alpha is greater than or equal to the p-value? Remember the result? We reject H0. And in this particular case, alpha is 1%. The p-value is approximately 0%, that we just worked that out up there. And so alpha is indeed greater than or equal to 0, so again that implies that we reject H0. So we get the same result.